A warm welcome from my side. My name is Oliver Gappa. I'm Sales and Marketing Manager at DVS. Hello, Tom. I want to tell you a little bit about Venice, telling you some buzzwords and so on. How does it fit in the workflows? Broadcast is a little bit new for us. And so we started to design a server that reaches a little bit the best of two worlds. So on one side, we wanted to have as much broadcast as possible inside the box. So video, audio, timecodes, protocols, reliability, redundancy, whatever is necessary there. On the other side, we wanted to have an IT-based system that is easy to manage. As open file systems, as open operation system as really possible to easy migrate the server. And we have chosen Linux as a platform for this server. Build a powerful platform around with our video boards on it. And Venice is a result. So what is it? It is a 2 or 4 I/O port channel server for SDI and HDSDI. You can real-time capture and seamless playout of any Sony, Panasonic, Avid or other encoded media. Most commonly used codecs and containers are supported. We have a channel-wise local GUI, a remote GUI, playlist, serial remote control, etc. We have an internal SAN or external SAN NAS storage. What does it mean? The internal disk pack inside the store server is organized as some kind of SAN. It uses store next file system under normal circumstances, so you can directly attach on the outside clients to it, browsing this content while it's ingesting to it. We have P2 card readers, professional disk drive support, templates. It's an OpenOS platform, as I mentioned before, and we have all Exchange protocols available for the system. So if I go into hard and software details, there are two 12-core Intel CPUs. We have RAID 1 mirrored system drives, redundant power supplies, an internal RAID 6 storage with current SAS drives to have the performance for 4 streams. We have 2 gig E connectors on board, LTC RS422, this is standard, and digital 3G. I/O means SDI up to 1080p 5060 capable, additional DVI and soon HDMI on the box as well. We support a lot of codecs with the system, and because we have chosen Linux at the very beginning, we had the problem that we had to migrate and integrate all these codecs by ourselves. So we have running contracts with most of the vendors directly because we have migrated the codecs by ourselves. So no toolkits or anything else. The result is better speeds than any of the other boxes on this Linux platform. And we could supply multiple real-time scenarios our competition couldn't. Because we have a very flexible storage array built in over the StoreNext file system, so this machine is already acting as some kind of mini SAN, you have several opportunities to connect your external clients directly to the box. So we can act as a NAS server, we can act as a NAS client, as a SAN client, or as an FTP server directly. On the one side, Linux gives us this opportunity. On the other side, the StoreNext file system opens this very easy for us. When we see on the back side, it is still a video machine. So it is as much IT as possible, but we need video IOs in a robust way. So you have a chassis with redundant power supplies. You have the BNC connectors for up to 4 channels in dual link. You have RS422, and you can have extenders for this as well if you need more ports. You have DB15s and LTC, so everything you need on a classical machine to support 4-channel I/O. In Venice, we have a lot of GUIs. We have the standard GUI, we have a remote GUI, and because we have chosen Linux on one side and we wanted to have an open and easy architecture, we have built from the very beginning external GUIs for Linux, for Windows, and for macOS. So independent from which platform in your network you control the system, it works on any. We have GUI-based playlists, GUI batch lists, a GUI for multi-channel modes. We support the classical, as mentioned before, Sony 9-pin protocol via RS422, master-slave. We support VDCP fully via RS422 or via SOAP. We have a complete API that is defined, so any function inside the box could be reached externally via SOAP commands. And that is very helpful to migrate into different applications. So whatever it is, a quality insurance application like the Baton one we have seen here could be easily migrated, the migration to a new system, and so on, because it's all SOAP-based. Finally, also MOS is implemented. Also, this is a SOAP-based application. So it works via IP network, and we have used the same API to migrate this operation. This is the architecture in an abstract. So we see that we have the Venice server. And we have the Venice client software and the server software. We have the video boards and the storage. And we see over the network, we can have multiple Venice client software systems that could be connected over the network controlling it. And that works also for multiple instances of the system. So it's a simple IP address you're connecting to a channel, and you hook on the channel, and then you control it and do whatever you want to do with it. Either ingest, either outgest, either transcode, whatever you want. That is an impression how the GUI looks like. On the right side, you see the main GUI, which is always looking the same, either if you're in ingest mode, if you are in playback mode or in transcode mode. You see the video, then you have timecode, you have machine operations, you can choose the resolution you're working in, you have the audio panels, then you can choose codec and destinations for it. That is a little bit more in depth. Also here in ingest mode, for instance, at the beginning you have, or at the top you have Venice and player. What does it mean? So we can either choose if the direction is coming from a VTR towards Venice or from Venice towards a VTR. This is just by clicking the direction. Then we can do a crash record or batch record, so the normal VTR modes as usual. We can insert the time code into the MXF header or into DPX. The system could work uncompressed up to the highest compression. It's very flexible. The video settings is there's an auto detect button. So if you put on a signal, you press the auto detect and it says you, oh yeah, you're working in SDI mode and you have 1920 to 1080, 25p or whatever. And the whole settings are following this automatically. After this is detected, it gives you only the opportunities to record the material corresponding or the corresponding codec that allows the raster you've chosen. So it doesn't allow mistakes at this time because you can very often generate, let me say, files that couldn't be played back by any other device because the codec is not supported for this raster or something like that by an Avid machine or something, another system. So this is another part of the GUI that is a multi-channel GUI. Since a long time, DVS systems from whatever generation supported to be linked by master-slave connectivity to build larger groups which are in sync. Here we have chosen a different way. So we use one of the network panels of any of the Venice, and you can group up to hundreds of Venice systems via this mechanism and track a separate IP port to track the grouping of the channels. You have this tool also coming with the box. You can select how many channels you have in your box. So it first browses how many channels you have. Then you can build groups between them, playout groups, ingest groups, and so on. And you can build these split views. You see always what's going on in all of your channels. And you have them absolutely in sync. It's internally synced. So it's just necessary to have a genlock or a sync signal to one of these channels. All the others will follow and will be absolutely in frame sync. Spicer. That's the second application coming with any DVS product. Either it is a post-production system like the Clipster, or it is a Venice now. This is DVS Spicer. It's our mini MAM. It's a software for content and storage management. So this is the general view you get when you open a Spicer with some media footage on it. You have two trees, right and left, to browse your entire network. So it searches down all the machines it could find that are mounted to the network. We have these Spicer clients also available for macOS, Windows, and Linux. And the browse clients are free of charge, so you can download them freely, get a license for it. Only the manipulating clients cost money, but when you browse, you can have as many as you want to. Even the browsing clients comes with a database integrated. And what does Spicer do? It indexes the file system. So whenever you install it on a machine, it starts indexing your whole file system and all the content that is on it. Then it stores all these index data, this metadata, in a smaller SQL database. And when you then drop a command towards a SpicerNet to search for some content, it is just the exchange of SQL commands towards the different Spicer instances, which is very fast, very efficient, and much faster than any other search routine running over your whole entire network and blocking it maybe. So what does its software do? It's a rapid media search function. You typically support DPX header structure, also MXF header structure meanwhile, so we extended it massively for broadcast demands, indexing of logical storage units, file event usage, content directions and networks, all on heterogeneous OSs, as I told before, all locally mounted storage units as well, up to a memory stick could be indexed. Huge amounts of data could be browsed very easily. We can also create low-res clips in Spicer. We can also create them in Venice. Meanwhile, you can choose between MPEG-1, MPEG-2, and MPEG-4 proxies. So either Spicer could generate these for you and store them on a location of your choice, or Venice does it even on ingest. So whatever you prefer, later on as being an offline or browse client, we can build these. You can remotely browse this proxy media. This is also saving bandwidth. So if you have a lot of logging clients searching for your material later on, it's much easier to browse just MPEG-2 or MPEG-4 files instead of searching for the bigger uncompressed media or low or high-res material. We display modified timecode and keycode. We display sequences of clips as well as all the compressed and codecs we support. We create, use, and search dynamic metadata inside. We have file data tag coming with it and preference list. You can add your own data tags if you want to. You can add your own search functions. It's a very flexible tool. That is one of the elements that is also coming with it. It has a scheduler and a job list. A scheduler means you can schedule in jobs when you want to move data, copy data, delete data, and so on. You can schedule this over events. You can schedule this over times. And everything the system is doing, what is current has done, and so on, is documented in either the job list and log files. So you can document whatever material is moved, somebody has deleted something, etc. It is in log files documented. That is, for example, the metadata view. That is one of it. So we support and read out nearby any metadata that is coming with the file itself, and you're able to edit this metadata as well. Spicer has a web service interface, as I mentioned before. So we have a massive, we use the SOAP protocol as a communication layer to provide metadata access, media access, and management, and job control. So any of the functions could be reached. There's an SDK available. You can write your own routines to it, use the search functions, etc., to move your data and copy it to something else, or let me say, transport it to another application you may use. And this is a very flexible way to reach not only Spicer, to reach all DVS products, because for example, project file definitions and many other things are very common to all our products. And you can, meanwhile, completely manipulate them from outside. So one of the new things we have, for instance, also in Clipster in the 4.0 is the opportunity to write external batch lists and templates. So you can fully automatize your jobs you have to do for the next day, and let the system do them overnight, and when you come back in the morning, they're done. A short word to SpicerNet. SpicerNet isn't a server-client application, so whenever you install it, you don't have to buy an additional server. Spicer runs on all clients itself, so it indexes the material that is connected to these clients, and not a separate server. A separate server always has the risk, if the server is down, all your metadata information is gone. Here, if one client is down, just the information of this client is away, but all the others is still available. And because you just send a few commands between SQL databases, the generic load the machine gets additional is very low. So we prefer this method